Hello everybody, in this lesson I will discuss some practice examples on two-way contingency tables in probability. Example 3. 400 drivers were interviewed about the number of accidents they were involved in during a calendar year. The results were summarized in the table below. So we've got in the first row, age of driver, number of accidents total, and then also 2 or fewer, more than 2 accidents. And then when you go down in the first column, age of driver, 40 years and younger, older than 40 years, and total. Number 1, calculate the values of B, C, D, E and F in the table, and then we can start by finding C's value. 200, 300, remember 200 plus matter. So 200 plus 100 will be 300, and then if you find B, 200 plus 50 is 250, and my advice to you is write it inside your table. So there's B 250, there's C 100, so D will be 150. When you go down you add, E will be, now you're going to add across, E will be 100, 50 plus 50 is 100, and F will be 400. 300 plus 100 is 400, and then you can also just check if you were right if you go across. 250 plus 150 is indeed 400. So there's your values. Number 2, is the number of accidents independent of the driver's age? Support your answer with appropriate calculations. So this independent, again, we find down there in the blue cloud, the product rule for independent events is probability A and B equals probability A times probability B. So we start by saying event A is a person is 40 years and younger. And then event B, 2 or less accidents. So then we're going to work out the probability of A is 300, it's this one, the total, 300 over 400, 0.75, and the probability of B, 2 or less, 2 or fewer accidents, is this 250 over 400 is 0.625. And then we do probability A and B. Probability A and B is that number over there. It's 200 over 400, which is 0.5. So we find this one is 0.5. Then we're going to do probability A times probability B, which is this 0.75 times 0.625, and we find the answer 0.46875. So can you see the left hand side is not equal to the right hand side, therefore events A and B are not independent. Example 4. 236 students were asked what type of sneakers they like. The results are shown in the table. So the type of sneakers, boys, girls, total, and when you go down, brand A, B, C, and total. 4.1. Are the events boys and brand A mutually exclusive? Justify your answer. Can you remember there's a rule? Mutually exclusive events, probability P, A and B must be 0. Therefore, event A, student is a boy. Event B likes brand A. Therefore, probability A and B is 48. It's this one. 48 over the total, 236 is 0.203. It's not 0. Therefore, probability A and B is not 0. Events A and B are not mutually exclusive. 4.2. Prove that the events boys and brand A are dependent. We've got the product rule for independent events is probability A and B is equal to probability A times probability B. So let's work it out. Probability A is 120, so that's boys, over 236 is 0,508. And then probability B, brand A, is 100. It's this one. Over the total, 236 is 0,424. Therefore, if you multiply the two, probability A times probability B is 0,215. And then probability A times probability B is not equal to probability P, A and B. Let me just show you. In other words, this one was 0,203 and these two was 0,215. That's what I mean. They're not equal. Therefore, events A and B are thus statistically dependent. This is Miss Pythagoras signing off. Till next time.